Okay, 1.2 in the pre-calculus for 150 to Lippmann-Rasmussen, 1.2. We're supposed to find the domain and range of these ones here. Excuse me. So the square root, we don't want to have a square root of a negative. And you need to know that being not negative means that x minus 2 must be 0 or greater than 0. And if you add 2 to both sides, you get x has to be greater than or equal to 2. So in interval notation, equal to 2 and getting bigger. Always do the smaller to bigger. So here we have a square root. It has to be 0 or bigger. So 6 minus 2x is greater than or equal to 0. Can't be negative, can't be less than 0. So we add 6 or subtract 6 from both sides. And then if we divide by negative 2, we get x, and dividing by negative flips the sign 3. So x, the numbers can be smaller than or equal to 3. So smaller than 3 starts at negative infinity and works its way up to 3, including 3. Here we have division, and you can never divide by 0. So this denominator cannot equal 0. So if you add 6 to both sides, you get x cannot equal 6. So in interval notation, we can use all the numbers from negative infinity all the way up to 6, but not 6, union, starting just past 6, not 6, but just over 6 up to infinity. Here, we don't have any square roots, but we can never divide by 0. So 4x plus 2 cannot equal 0. Subtract 2 cannot equal negative 2. Divide by 4. X cannot equal negative 2 fourths, which is negative 1/2. So it can be anything below it from negative infinity up to negative 1/2. Always go smaller to larger on the number line, left to right, union, and we can go just above negative 1/2 all the way to infinity. We can use everything except that. Now I could have written this one, all reals except 6, and that might be easier. And this one might have been easier to say all reals except negative 1/2. Now here we have two issues. We can't divide by 0, and we don't want the square root of negatives. So we're going to have to look at both of those restrictions. So the x plus 4 has to be 0 or greater. Subtract 4, so x has to be greater than or equal to negative 4. And we don't want x minus 4 to be 0 because we can't divide by 0. So it cannot be 0. Add 4 to both sides, so x cannot equal 4. So on the number line, we can't be equal to 4, and we have to be bigger than negative 4 or equal to it, but we can't be there. So we got two pieces of segment. So in interval notation, we'd say from negative 4 up to 4, union from 4 to infinity. You could say all reals greater than or equal to -4 except for 4. You could write it out in words. Okay, this one there's no square roots, but we do have division. So x squared plus 9x minus 22 cannot equal 0. So let's find out what makes it equal to 0 by factoring this. And if I line up 0 and 9 on my strips of paper and I need to get minus 22, one of these has to go minus, so I can go -1 and 10 is still 9, or -2 and 11, which multiplies to be 22, so it's x minus 2, x plus 11 cannot equal 0. Well, 2 would make it equal to 0, so x could not equal 2, and x equal -11 would make it equal to 0, and we can't be that. So we could say all reals except 2 or -11, or we could go from -infinity up to -11. That's the first of these two we run into. Union from, continue on from -11 up to 2, but we can't use 2, union, but we can use above 2. Okay, now we're supposed to find out f of -1, 0, 2, and 4. So f of -1. So we have to decide, is -1 less than 0 or greater than or equal to 0? Well, it's less than 0, so we use this formula. 7 times -1 for the x, so that's -7 plus 3 is -4. F of 0. Well, 0 is not less than 0. It is greater than or equal to 0, so we use this one. Putting 0 there, we get 7 times 0 plus 6 is 6. F of 2, that's greater than or equal to 0, so we use this one. So 7 times 2 is 14 plus 6 is 20. And f of 4 is also greater than or equal to 0, so 7 times 4 is 28 plus 6 is 34. Okay, this one. On this one, I'll do it over here. F of -1. -1 is less than 2, so I use this one. -1 squared is 1 minus 2 is -1. F of 0. 0 is less than 2. It's not greater than 2, so we use this one, and we get 0 squared, which is 0, minus 2, which is -2. Then it says do f of 2. Well, 2 is not less than 2. It's equal to 2 or greater, so it's equal. So we got to use this one. So 2 minus 5 is -3. Absolute value of -3 is +3, and +4 is 7. And f of 4 is greater than 2, so we use this equation. 4 minus 5 is -1. Absolute value of -1 is +1, plus 4 is 5. So there were questions on those, so I did those, and then I'm going to do 48. Some people were struggling with that. Okay, well, I'm going to pretend like this is the graph right here. Dave leaves Padelford Hall and walks at a constant speed till he reaches Gould Hall 10 minutes later. So if I make this time, and this is 10 minutes, it would be, and if Gould Hall was some distance away, I think it said it was 240 feet long. This would be 240 feet, and he would get to 240 feet in the 10 minutes. So this should have been lined up here with 240. So I'm moving 240 to there. If he leaves Padelford Hall, and this is supposed to be the distance between this hall and Dave, and so that's why it's 0 difference here, and he is now 240 feet from Padelford Hall. When he gets to here, he's 240 feet from that. Now he leaves Padelford Hall and walks at a constant speed, and it takes him 6 minutes to get the halfway. So if this is 10, here's 5 minutes. Now this is going to be confusing because this looks like how far it is. I better not do that here. I better switch. Let's go back to here. 10 minutes and 2400. So he went at a constant speed and got there in 10 minutes. That's A. B. He left and got halfway at 6 minutes. Halfway is that distance. So he got that far, gets confused, stops for a minute. So now he's at 7 seconds. And then he continues on at the same constant speed as when he originally left. So he's going slower. Took him 6 minutes to get halfway. So it's going to take him 6 minutes from the 7 minute, which is going to take him to 13 minutes for him to finally reach the 2,400 feet from Padelford or reach Gould Hall. So it should be here, flat, and then up at this same slope here as here. The next one, he leaves Padelford Hall and walks at a constant speed. It takes him 6 minutes to reach the halfway point. Gets confused, stops for a minute, and then then he continues at twice the constant speed that he originally had. So it's going to normally take 6 minutes to finish it at the speed he had, but he's going twice as fast, so it's only going to take him 3 minutes, so he'll reach there in 10 minutes. And the final one I don't have here is someone's leaving Gould Hall and coming back. And so that would have to start 2,400 feet from Padelford Hall and walking back to Gould Hall, and that would come down. And I think that person just did a constant. I don't have that here, but it would be something like that. Okay,